Okay, 5.3, basically I'm going to be giving you different functions and you need to tell me if they're linear or exponential. From the equation, that should be easy, okay? Linear has an x, exponential has a power or a number to the power of x or an exponent in it. With tables, it's a little bit trickier, although we've already talked about it, but I do want you to highlight this. You need all x values in the table to have a common difference, because if our x values are not increasing by the same number every single time, it's not going to be a function at all. It's just going to be all over the place. But if all of the y values have a common difference, then the table represents a linear function. So common difference is linear, which we talked about in the previous notes, right? If you're adding the same number every time, it's linear. If you realize that all of the y values are being multiplied and they have a common ratio, then the table represents an exponential function. So common ratio is exponential. Okay, so now it's actually written down somewhere. So let's look at the two problems that they give us. In part A, they already put the ratios and the differences for us, but we can still talk about it. Look at your x's. Is there a common difference with the x's? Are they all increasing by the same number? Yes. Now, what about the y's? Do those have a common difference or a common ratio? Ratio, because we're multiplying. So is this table representing a linear function or an exponential function? Exponential. So we would say it represents an exponential function. And that is because, well, we have to talk about the x values also. So because the x values have a common difference, but the y values have a common ratio. The reason that it's important that the x values have a common difference is because what if I plugged in x values like 0, 3, 25, and 107, but then all the y values are still being multiplied by 3? Does that give you an exponential function? No, because the x's have to be increasing by the same amount. Okay, so we have to also include the x's. Look at part B. Do my x's have a common difference? Now, do my y's have a common difference or a common ratio? So what type of function is this? Linear. And it's linear because the x values and y values have a common difference. From an equation, you should be able to tell pretty easily, but for the charts, it's a little bit trickier. The other thing that we're going to be looking at is the rate of change. So let's think about this really quick. If my function is a linear function, so that means it has a common difference, do you think it would have a constant rate of change or a not constant rate of change? Think about what a linear function looks like. Is that a constant rate of change? Yes. What about exponential? Exponential grows kind of slow and then shoots up really fast. Is that a constant rate of change? No. So we can also determine if something is linear or exponential if we look at the rate of change. So how do we find the rate of change? Another word for rate of change is, starts with an S, ends with a lope. Slope. Okay, so here's the formula for you. The question will be worded slightly differently, but the work is actually the same. So the average rate of change for a given interval. So they're going to give you the intervals. A and B are going to be your endpoints. You just plug in f of B minus f of A, that's y1 minus y2, over B minus A, x1 minus x2. So remember, you just make sure that you plug in the same y and the same b. Will you next to it write slope formula? It's the same thing. Okay, rate of change and slope are the exact same thing. It's just that this time we're not looking at the graph, we're just looking at the table. Okay. So turn to the next page, and I'm going to show you an already worked out example, and then we're going to do one ourselves. Okay, guys, so for this problem, the question is, what is the average rate of change for the function f of x equals 2 times 2 to the x over these three intervals? -2 less than or equal to x less than or equal to 0, 0 less than or equal to x less than or equal to 2, and 2 less than or equal to x less than or equal to 4. How do I know what values I need to plug into the table? Everything between -2 and 4. Because I need to go -2 to 0, which is -2, -1, 0. 0 to 2 is 0, 1, 2. And 2 to 4 is 2, 3, 4. What's another way they could have told us what values to plug in? -2 less than or equal to x, which is less than or equal to 4. So this and all of these individual ones actually mean the exact same thing, okay? Because it's telling you what x's to plug in. How did they get the y's? They plugged in those x's to the function, okay? So then the question is, find the average rates of change over these intervals. The first interval is between -2 to 0. So slope formula says that we have to do the y's divided by the x's. And I usually like to go from biggest to smallest. So what is the y that is associated with 0? 2. That's how they got 2 right here. What's the y associated with -2? 0.5, so minus 0.5. And then we have to subtract the x's. 0 minus -2. That's how they got those. But subtracting a negative gives you a positive. So the rate of change came out to 0.75. Okay. For the interval 0 to 2, the rate of change came out to 3. And for the interval 2 to 4, the rate of change came out to 12. What do you notice about those rates of change? Times 4. Is it a constant rate of change? No. If it was a constant rate of change, then all of these should come out to be exactly the same. So is this rate of change constant? No. So it's not constant. Because they're all different. And then, Chewy, how did you know that they were all being multiplied by 4? I guess. You guessed? Yeah. Okay, guys, what's 0.75 times 4? 3. It does come out to 3. 3 times 12 gives me 4, or 3 times 4 gives me 12. Why am I multiplying my rates of change by 4? Because the number... kind of. Look at what is my ratio for this equation? 2. Every single time I'm multiplying by 2, right? To get to the next y? Yes? Okay. But look at the rates of change that I'm looking for. I'm looking for the rate of change from 0 to 2, or from -2 to 0. If I'm going from -2 to 0, how many times am I multiplying 2? Twice. Twice. So this is times 2. Times 2 again actually comes out to times 4. Does that make sense? So because we're skipping over one of them, because we're finding the rate of change between every 2 values, not every 1 value. If I was looking for the rate of change between every 1 value, what would it come out to be? 2. What if I was looking for the rate of change between every 3 values? 2. No. 2 times 2 times 2 is 8. Okay? So that's what we're doing. So let's actually do this ourselves. Look at those bottom 3 exercises. I think it makes a little more sense when we actually do it. Does this table represent a linear or an exponential function? And let's explain. First, let's check the x's. To go from 0 to 1, what do I do? Plus 1. What about 1 to 2? Add 1. And 2 to 3? Add 1. Okay, let's look at our y's. 15 to 20, 20 to 25, and then 25 to 30. How do I get there? Okay, so is this a linear or an exponential function? This is a linear function, and then you do need to explain, and that would be because x values and y values all have a what? Common difference. Okay, so you do need to explain why. Okay. You will also be asked, given a situation in words, if it will be modeled by a linear or an exponential function. So let's look at number 2. Suppose the fish population of a lake decreases by half each week. Can you model the situation with a linear function or an exponential function, and why? If we're taking half of the population each week, what are we actually doing? Times 1/2 or dividing by 2. So is that linear or exponential? Exponential. And why? Because you are multiplying by 1/2 each week. Okay. So this last one says to find the average rate of change for this function, 2.5 times 2 to the x over these intervals. 1 less than or equal to x less than or equal to 3, 3 less than or equal to x less than or equal to 5, and 5 less than or equal to x less than or equal to 7. We have to start by making an xy table. How do I know what values I'm going to plug in? It tells me. What's the first one I need to plug in? 1, and then I need to figure out 2, and then 3, 4, 5, 6 to 7, right? Okay. So let's see if we can figure it out. If I plug in 1 to this function, 2 to the first power is what? 2. And 2 times 2.5 gives me 5. Okay. If I plug in 2, 2 to the second is what? 4. And 4 times 2.5 is 10. Okay. Anybody have a guess what the next one is? No. The next one is 20. What would be the next one?
40.
And then 80, 160, and
320.
320. How could I do that without having to plug it in every single time? Yeah, look at the equation. What does the equation say our ratio is? 2, which means you multiply by 2 each time. Shortcut, right? Okay. So then we need to find the average rates of change. So from 1 less than or equal to x less than or equal to 3. Let's do that one first. What's the first y value I have to use? 20 minus, what's the y value that goes with 1? 5. And now our x values have to be the same order, so 3 minus 1. 20 minus 5 gives me 15. 3 minus 1 gives me 2. And that 15 minus, or divided by 2 gives me 7.5. Okay. The next interval was 3 less than or equal to x less than or equal to 5. What's the first y value I'm going to plug in there? What's my first y value? 80 minus what? 20. So 80 minus 20, and then our x's have to be in that exact same order, so 5 minus 3. 80 minus 20 is 60, divided by 2 gives me 30. And then this last interval is 5, less than or equal to x, less than or equal to 7. Okay, so that's going to be 320 minus 80 all over 7 minus 5. Anybody know 320 minus 80? Good. 240 divided by 2, 120. Okay, look at my rates of change. Is it constant? No, not constant. Okay, and actually, what am I multiplying by each time? Times 4 again. Why? Because I'm looking for rates of change for every two numbers, and 2 times 2 gives me 4. Okay?